Hello, I'm Engineer James Okorie, the founder and director of James Okorie Technical Institute, where you will learn everything that concerns automation. Today, I want us to look into overload relay. Now, if you are into electrical and you are not into industrial, you will be limited. Don't let your career to be limited. So that's the reason why I'm here to teach you everything that concerns automation. And today, we'll be looking into what we call the overload relay. This component you are seeing here is very small but mighty. We call it thermal relay. Overload relay, thermal relay. It independently works on contactors. By the way, if you have not seen our videos on contactors, please scroll down the page to see the videos we made on contactors, including the practical videos on how you can be able to connect contactors. An overload relay is a component that enables us to protect our load from overload. What is overload? Let's say, for example, you have a pumping machine that can carry can be used maybe to power one thing or the other. Sorry, let me not go into pumping machine. Maybe you have an electrical motor that is being used to drive something that is small, but because that motor has spoiled and you didn't see any motor that is as big as that one, you go and carry small motor and use it to power that big thing or to move that big gear. In that, by doing that, you are actually subjecting that motor to overload. Why? Because the motor will have an issue. Now, let's take a look again. Should in case maybe you have electrical fan in your house. Maybe as the fan is rotating, you go and carry, or maybe mistakenly, cloth particle or something enter the blade of the fan and then drag the two blades together, thereby not allowing the fan to move. You have subjected that fan to overload. So overloading a particular motor means that you are actually trying to spoil that motor by subjecting it to something that is bigger or higher than it. So when you look at this overload relay, it's rated in amps, it's calibrated in amps. The work of this overload relay is to automatically detect the current that is flowing to the motor, as well as to know when the current is higher than the set current. If the current is higher than the set current, what will it do? It will trip. So let's look at the diagram of this overload relay. We said that we have what we call the power terminals of overload relay. These are the power terminals of overload relay: T1, T2, T3. So with this overload relay, we attach it at the output of the contactor. So this is a contactor and this is overload relay. So how do we connect it? You look at the output of the contactor labeled T1, T2, T3, and we attach it to the output of the contactor so that the current that is coming from the in can pass through the out of the overload relay. When you look at this, see that these are the pins of this overload relay. These pins are directly connected to this output. So when you attach this pin to this, it means that if current is flowing from the input, the output should be from the output of the overload relay. So what do? We attach this to this. This contactor is rated in amps. Overload relays are rated and calibrated in amps. So when you want to use any overload relay, check the amperage that will work for you. Because when you look here, you see that this can be adjusted to any current that you want to achieve. So you buy the one that can be able to work with the load you are working with. Every overload relay is calibrated in current, that's in amperage. So you have to select the amperage that will work for you according to the load. By the way, if you don't know how to do the connection, and if you don't know how to do the calculation and rating, sizing of this component, there is video for you. So scroll down our page, check some of the videos. You will see that we have video on how to size the components, including the contactor, the overload relay, the pin relay, and every other components you are using for your installation. Now looking at this now, you see that this T1, T2, T3 will always be connected or attached to the T1, T2, T3 of the contactor. So if this is T1, T2, T3 of contactor, we have to attach this overload relay power terminal T1, T2, T3 to this. So it means that this is going to be connected to this, this is going to be connected to this, this is going to be connected to this. So if the input of this contactor is L1, L2, L3, just like this, So it means that if this and this are open, and this and this are open, this and this are open, it means that this overload relay is attached to the T1, T2, T3, because from this contactor you will see that this is the input and this output. So overload relay power terminals are always attached at the output of the contactors. Now let's look at the other terminals which are labeled the normally open and normally closed. When you look at contactor coil are always labeled A1 and A2. So if this is A1 and this is A2 and this is coil of this contactor, it means that for this contactor to energize, the coil of the contactor have to be supplied with appropriate voltage level that can function with that contactor. So for this overload relay to control the coil of this, we'll be using normally closed overload relay, because the control terminals of overload relay are either normally open or normally closed. So normally closed is labeled 95 and 96. By the way, anything labeled 5 and 6 on overload relay is normally closed, and anything labeled 8 and 9 is normally open. It might not necessarily be 5 and 6. Alright, it can be 55, 56, it can be 75, 76, mostly it can be 95, 96. Sometimes on normally open it can be 25, 27, 28, it can be 87, 88, it can be 97, 98. So in this case we are using 97 and 98. So for you to control anything that concerns this contactor coil, always use normally closed. The reason why we use normally closed is that normally when this overload relay have not detected any fault, the normally closed still remain normally closed, meaning that current can flow from the normally closed to energize the contactor. Then when there is an issue in the system, it will trip, being the overload relay, and when it trips, that normally closed will turn to open, thereby de-energizing the coil of the contactor, and because of that, the load will stop working. So that's how we use overload relay. If you want to see the practical way at which we connected this overload relay, always follow us and check our videos. We have done a lot of practical videos concerning how to connect overload relay, and we have gone to so many factories whereby we make videos and we show our followers how the overload relay is being used in factories and everywhere. My name is Engineer James Okore, and I'm the founder and director of James Okore Technical Institute. My duty is to teach you everything that concerns automation. Here at James Okore Technical Institute, we teach everything that concerns solar energy and inverter installation, CCTV camera installation, industrial control panel automation, smart home automation, everything that concerns electrical wiring, practical, hands-on practical training. Alright? Follow us, subscribe to our channel, and you can send us a WhatsApp message or call us on the number you are seeing on the page. Thank you very much.